Hi everybody, it's CM Science and Math Tutor, and today we are going to be talking about chemical bonding. So first we're going to talk about the types of atoms involved with ionic, covalent, and metallic bonding. So for ionic bonding to occur, we must have a metal and a nonmetal. For covalent bonding to occur, we must have two nonmetals and for metallic bonding to occur, we must have metals and metals. So two metals. So next we're going to talk about the method of bond formation. In other words, how do these bonds occur and what is actually happening in order for the bonds to occur? Are they shared? Are they transferred? Are they traded? And this section is very important. So are the transfer of electrons. And this occurs from the metal to the nonmetal. It's also important that you know that positive ions and negative ions are attracted to one another. And this is the way the bond occurs. Now, for covalent bonding, we, instead of having a transfer of electrons, we have a sharing of valence electrons. And this occurs between two nonmetals, like we said before. And the important thing about covalent bonds is that we are ensuring that each atom has an octet. And an octet means it has a full outer shell. And this does not necessarily have to be 8. It usually is, but in some cases it can occur with 2. And in a later video, we will talk about the exceptions to this octet rule with covalent bonding. So really, we should say a full outer shell. And for metallic bonds, valence electrons they are shared among all the atoms. Many teachers refer to this as the sea of electrons. And this occurs with positively charged cations. So it's basically a bunch of cations floating around in this sea of electrons, and they're attracting to valence electrons. So what type of structure do ionic bonds form? Ionic bonds form a crystalline, which is regular, or a crystal lattice, and the crystal lattice can be regular and repeating. Usually, especially in chemistry and AP chemistry, we refer to ionic bonds as having a crystal lattice structure. And in covalent bonding, we have a molecular structure. In other words, a molecule is formed. And metallic bonds have a crystalline regular structure. And electrons moving all the way throughout the atoms. I'm going to talk about the physical state of ionic, covalent, and metallic structures. The physical state of an ionic compound is solid. Because of its crystal lattice structure, it will always be a solid. Covalent bonds are, of course, different because they do not have this crystal lattice structure. They can form to be liquids or gases. And then when they are solids, they are very low melting point. And that's a more rare situation. They usually typically occur as liquids or gases. And metallic bonds are always solids due to their crystalline regular structure. Next, we're going to talk about melting point. An ionic bond has a very high melting point. And to give you an example of this, NaCl has a melting point of 800 degrees Celsius. And that example is MgO, magnesium oxide, and that has a melting point of 2,852 degrees Celsius. Covalent bonds, on the other hand, have low melting points. An example of that would be CCl4 with a melting point of negative 23 degrees Celsius, and H2O. That's a very common example. You're probably familiar with it, 32 degrees Celsius. Degrees Fahrenheit. Or 0 degrees Celsius. And lastly, we have metallic bonds, which have high melting points. And an example of this would be aluminum. The melting point is 660 degrees Celsius. Or we could also talk about copper, which has a melting point of 1,800 or 1,084 degrees Celsius. Now, which of these bonds are soluble in water? Is an ionic bond soluble in water? Yes. Is a covalent bond soluble in water? No, it is not. And is a metallic bond soluble in water? Definitely not. Now we're going to talk about electrical conductivity, and I'll elaborate on each of these answers a little more. An ionic bond is kind of conductive in terms of electricity because they can conduct electricity. when they're melted or dissolved in water. Covalent bonds are not, covalent compounds do not conduct electricity no matter what. And metallic bonds do conduct electricity, and metals conduct electricity as solids and when they are melted. Some additional properties that don't necessarily fit under any categories together but are important to know. Most ionic compounds are hard, and most ionic compounds are brittle. For covalent compounds, some are flammable, and they are poor conductors of heat. And for metallic bonds, most metals are malleable, and some people don't know what malleable means, and that means they can easily be hammered. And most metals are shiny and hard. Here are pictures of ionic, covalent, and metallic bonds. As you can see in our picture of the ionic bond, lithium is just transferring or giving an electron to fluorine. As you can see in the picture of covalent bond, this is H2O, water, and the hydrogen and oxygen are sharing electrons, so they can have a full outer shell. And the metallic bond is this kind of sea of electrons. There are cations, positive charges just floating around a sea of electrons.